We can also write generic functions that have more than one type parameter. So a simple example, a pretty common one to illustrate this concept would be something like a function called merge that accepts two objects. So we have object 1 and object 2. And then it's just going to merge their properties together. I'll use the spread operator. So object 1, and object 2. So whatever you pass to it, object 1 and object 2 right now are of type any. There's no generic anything going on. Just type any. It will return a new object that contains both of their properties combined, right? So just to demonstrate this, if I had merge this object that has name is Colt, and then pets equals Blue and Elton. And then if I just console.log that, just so we can take a look, there it is. We see our new merged object. Okay, so what type do we get back, right? If I store that in a variable, right now, const combo object equals that. What type in TypeScript's mind is combo object? It's our bad friend any, right? It's the least helpful thing on earth when we're working with TypeScript. And we have strict mode enabled right now, so we're going to get a complaint anyway that says you have an implicit any type, you don't want that. That's bad. So we could manually annotate that as any, but we don't want to. This is about generics. So instead of doing that, what we can do is write a generic function, merge, but it's not just going to accept a single type parameter. It's actually going to accept two, one for each of these, because they're going to be of different types, or at least they could be. That's the point. They're not going to be the same pattern, right? They're not both, I mean, they could both just be an object that has a name or pets, but why would we merge them together in that case? I don't know. So the convention is to then, for your next type, to give it a U as the name. Just like if we have a for loop, right, we use I as the letter, and then if we have a nested for loop, we'll use J, and then a third nested, we'll use K. So same pattern. It's just a common thing to do. So you have T, and if you need a second type parameter, you would go with the next letter in the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, Q, R, S, T, U, and then V, and hopefully you don't have more than that. But if you do, the pattern is just to keep going in the alphabet. So now we can say, all right, well, object will be of type T. Object 2 will be of type U. So we don't have to change anything else. We're not going to tell TypeScript what this returns because it will infer, if we just look now at merge, it infers that the return type is an intersection between T and U. And that's true. TypeScript is smart. It figures that out. So if we look at combo object, right, we can see what the return type is. Based on what we provided, these can be a shape, really any object shape. It doesn't matter. But TypeScript can tell what we're going to get back. We're going to get back an object that has name and pets. So instead of just any, right, which we saw earlier, if we didn't have this in here, we get rid of this. TypeScript doesn't know anything about what it gets back. It just knows that it's of type any. But by making this a generic that has these two type parameters, we don't do anything with them except say, all right, TypeScript, this first object is of type T, the second object is of type U. Now TypeScript can say definitively that the return type is the intersection between T and U. And this is also another example where TypeScript is able to infer the generic types, right? The type parameters. I don't have to do this. Merge, and then the first type is an object that has a name that's a string. The second type is an object that has pets. That's an array of strings. And then I execute it with my two objects like that. Thankfully, I don't have to do this. It's able to figure out based upon when I just called it, right, and the two arguments I provided, it's able to figure out, all right, well, there's this thing. It has type name, and it's a string, and then it has the second argument is of type object with a pet property set to an array of strings, and then it can figure out that the end result the combination, the intersection of the two will be a new object with this type. Name must be a string, pets must be an array of strings. Very long-winded explanation, but hopefully you can see how a generic helps us here. Just try and compare that to if we left it at any. Object 1 can be any type, object 2 is any type. The code inside is exactly the same, but the knowledge or the information TypeScript gains about the return type is day and night. It's so much better than using any. So this was another example of a generic function, and also an example, our only example so far, of a function that has two type parameters. We use t for the first one conventionally, and then from there, if we need a second one, we'll use u. But these can be named anything. This is just what you'll see the most.